problem with renewable energy is the lack of continuous supply. Wind, sun and sea can be so inconsistent that we end up relying on fossil fuels as a backup. For renewable energy to be a real solution, we need to be able to store it so we can use it whenever we want, 24 hours a day.
British company Highview Power Storage has developed a pilot plant that stores energy using a resource that's all around us.
Okay, so this is the world's first fully integrated and fully operational liquid air energy storage device. Like any storage device, there are three main sections: a charging device, a storage device and a discharge device.
Show me around. Where does it start?
The first part of the process sucks in the air from around us and it pressurizes it. What we end up with is a high-pressure ambient temperature stream which goes into the large tower we see in front of us.
It's still a gas at this point?
Still a gas.
Okay.
So as the high-pressure air gradually progresses downwards, it becomes increasingly colder. Right at the bottom, it turns into a liquid.
So it's like a big fridge you've got going on there?
Effectively, yes.
Right.
Okay. Right, so if I take you over to the tank where we're storing the liquid air.
After being cooled to minus 196 degrees Celsius, the temperature at which air's main component, nitrogen, becomes a liquid, the compressed fluid moves on to the next phase, storage. This tank is at the heart of the technology. It's here that excess power generated by renewable sources can be stored to use at times when wind, sun and sea can't produce enough electricity to meet our demands.
And this tank here, how much energy is it actually storing?
This is a 60-ton tank. On this site, that's equivalent to about 2.5 megawatt hours of storage. And so we could say a village of 300 homes for about an 8-hour period.
And to release the power of liquid air, all you need to do is warm it up again. Exposing the sub-zero liquid to normal temperatures will do the trick. But at this plant, waste heat is pumped from a neighbouring power station to make the air expand more quickly, so it packs an even greater punch to drive a turbine.
Right, so this is the business end, so to speak, where the power is produced.
So this is where it all happens?
Yeah.
Another grey building.
This is a standard generator, effectively. This is the same sort of setup that you get in combined heat and power gas engines and diesel engines.
So you're actually using the same equipment now that would be found in fossil fuel plants, and that kind of thing?
Certainly this end of it, yeah.
And if that electricity comes in a renewable form in the first place, then you're at zero emissions?
Yes, exactly.
The plant is about to release some power back onto the grid.
Anti-clockwise, that's it, yep.
So I press this and everything
Yep.
starts to freeze? Oh, wow. They've taken the air out of the atmosphere, the air that we all breathe, they've frozen it and pressurised it and stored it, and now they've heated it back up, and that energy release is being used to drive a turbine, and right now, over 200 kilowatts is being produced and taken back to the grid.
Liquid air is seen as one of the most promising new ways of storing the power generated by renewable energy sources. Unlike other technologies, it's compact, can be located anywhere, and is made up of components that are already available.
It's standard machinery, so that makes it quite cheap, and there's also an infrastructure already out there for the handling of it and the transportation of it. So it's a proven technology put together in a novel way to produce a solution to a storage demand.